Hey everyone. This one says to use the addition property of inequality to solve the inequality and graph the solution set on a number line. So your first question might be, what in the heck is an inequality? Well, an inequality looks a lot like an equation, but instead of an equal sign right here, you're going to have a less than, or maybe it'll be less than or equal to, or it may be a greater than, or a greater than or equal to. It'll be one of these inequality symbols instead of an equation. Then your second question is, okay, how do I solve it? Well, you solve it the same way you would an equation. You add, subtract, multiply, or divide something to both sides. Just remember, what you do to one side, you have to do to the other, just like an equation. There's one major exception with inequalities that you don't have with equations, and that is if you multiply or divide both sides of the inequality by a negative number, then you have to flip the direction of the inequality. And we'll look at one of those examples a little bit later. Another general rule, and this is not required, but I think a good idea, is when you're isolating the variable, put the variable on the left and the number on the right. And remind me later, and I'll explain why I think that's important. Okay, so I'm going to solve this thing by subtracting 5x from both sides because I want to get the x on the left. I want to move my x's to the left. So subtract 5x from both sides. So 6x minus 5x is 1x. Bring down minus 5 is less than, and then here's my 13 just coming down because the 5x is canceled. Now I want to get x by itself on the left, so that says x minus 5. Well, we know what we have to do. Add 5 to both sides, and we end up with x is less than 18. And that's the solution. X is less than 18. My math lab is going to ask you to enter the solution in interval notation. Interval notation. Read the directions carefully. Right underneath the answer blank there, it'll say use interval notation. But to get to interval notation, I think it's helpful to draw the graph first. So I'm going to sketch the graph before I even try to enter that interval notation into my math lab. Well, x is less than 18, so I'm going to do a real rough sketch here. Here's a number line with 0, so I know 18 has to be over here. We want to shade, we want to graph all the x's less than 18. Well, if you're less than 18, then you're over here. So I'm shading to the left. I'm going to draw a little arrow because it doesn't stop. It goes forever to the left. And on top of 18, I'm going to put an open parentheses, because x does not equal 18. So we use an open parentheses whenever it's strictly less than. Now suppose this had been x is less than or equal to 18. If that had been the case, then instead of parentheses, I would be putting a bracket over the 18. Now I want to tell you about the thing I mentioned earlier. Why I think it's important to put x on the left. If you had written it with x on the right, your answer would have come out looking like this. And these are equivalent because in both cases the inequality is pointing toward the x, meaning the x is the smaller thing. It always points to the smaller thing. And so that's correct. But I'd say about half the time when students write the answer like this, they end up shading incorrectly. They end up shading to the right instead of to the left. So to avoid that common mistake, I'd recommend you just always put x on the left. Now to get the interval notation. Interval notation looks like an ordered pair, so I'm going to put my set of parentheses there. The left number is the smaller number. Well, there is no smaller number because it doesn't stop. It keeps going forever, so it goes to negative infinity. And I'm putting parentheses there because you never reach negative infinity, and you only put a bracket when you actually hit that number. Well, I never hit negative infinity. And I put parentheses on this side because the upper number, the bigger number, is 18, but I never get to 18 either, for the same reason we had the parentheses up here, because it was strictly less than. So again, the less than means it's going to be parentheses on the graph, which means it's going to be parentheses on the interval notation. And notice how the number line kind of mapped nicely to the interval notation. The upper end of the number line gives me the upper end of my interval. The left side of the number line gives me the left side of the interval notation. Okay, hope that made sense. If you have questions, let me know.